Hey students, now we're going to do the expression or graphical representation of the rate of the reaction, average rate and the instantaneous rate. Right. Now, how we can come to know about the rate of the reaction? For it, when a reaction proceeds, right, at different interval of time, there will be change in the concentration of the reactant, right, and there will be also change in the concentration of the product. Right, students? So, what we are going to do, we are going to just find out the change in the concentration at different interval for the reactant and the product. So when the reaction proceeds, what we will do, within a certain interval of time, we are just going to withdraw the reaction mixture, right, which will contain both the reactant and the product, right, and nearly 1 to 2 ml quantity we are going to withdraw from the reaction vessel or reaction mixture, and we will just freeze it out or cool it down so that we can arrest the reaction at that moment, right. And then what we will do, we will just, by the suitable method, we will just determine the concentration of the reactant or the product in that reaction mixture, and the suitable method which generally perform is the titration method, right. Now, the change in the concentration, so at a different time, can be when we come to know about the concentration of the reactant, right, or the product at different interval, right, we will plot a graph. Now, with the help of the graph, we will get a certain curve, right. Now, with that help, we can find out the average rate also, and we can also find out the instantaneous rate, right. Just have a look on the graph here which I have drawn, started to begin here. So we have got this. On the x-axis we have just mentioned here time, and on the y-axis we have got the reactant concentration. Now here students, we are drawing the plot graph with the time for the reactant variation. Now you know that as the time will proceed, what will happen? There will be decrease in the concentration of the reactant. So it is in this way, there is a decrease in the concentration of the reactant as the time proceeds, moves, right? Now we have to find out the average rate, right? So we will just we'll just get two time limits here, or we'll just get the time interval, right, with which we are going to find out the average rate. So let it be this time, right. So this is t1 and this is t2, right. So this is time interval. We are going to find out the average rate. We're just going to intersect, or we're just going to plot it straight, and we will just intersect it to the curve, right? And for it, we will find out the concentration at this time, right? Let at T1 it be C1, and at T2 let it be C2, right? Now, what is going to be the average rate, right? It is going to be the change in the concentration of the reactant with respect to the time. So it will be minus C2 minus C1 upon T2 minus T1, right. So finally we can say here it will become delta C upon delta T. So here the average rate is just, we have to find out the difference of the concentration and the time, right, with respect to the time. So in this way we can we will know this value, right. Value will be given to us and we can find it out. Now students, when we are finding out the instantaneous rate, right, for that, so it is time. This is I am expressing in this way, right? So concentration of reactant you can express in this way also. This is concentration of reactant here. Here, since this is again the graph which is related with the decrease in the concentration of the reactant, so we are going to get the curve in this way, right? Now, the difference lies here that for the instantaneous rate, we have to find out the rate at instant, that a particular instant will be there. Let it be this one, right. I want to find it out at this time, right. So what I will do, I will just going to get the point obtained on the curve, right. Once I obtain this point, this is the point P, I have to get the rate at this point, that is the instantaneous rate. What I will do, I will just going to draw a tangent at this point, right? So when you will draw a tangent at this point, doing this way, you are going to just extend it so that it just intersect the y-axis and the x-axis, right student? Yeah, this is there, right? Now what is there that we are going to find out, this is O, let it be this A, and this is B. So here the instantaneous rate, right, that will be equal to the, right, it will be equal to the slope of this curve, right? Now that slope of this curve, right, how you can do find it out, that is going to be the right, by finding out the theta angle, right? So you can find out this is going to be OA upon OB, right? So here we can write down that slope of this curve will be equal to OA upon OB, right? So we can also write it down in this way, R instantaneous equal to delta. Now this is in term of reactance, so I am putting here as delta R upon delta T, right? So mean is that we, by just finding out the slope of this tangent, we can find out the instantaneous rate, right? And you know that the slope equals to tan theta. So if the theta angle is given to us, right, you can do the, you can find out easily the instantaneous rate. So just by finding out the slope of the curve, right, you can find out the instantaneous rate. Now students, we are going to express the rate of the concentration graphically in terms of the product, right? Change in the concentration of the product, right? So you can see that the two graphs are drawn. So first look at here, this is the first graph where we are going to express, we are placing the time on the x-axis and the concentration of product on the y-axis, right? Now we will see that as the time proceeds, there is a gradual increase in the concentration of the product, right? Reactant disappears and the product begins to appear. So there will be increase in the concentration of the product here, right? Now we have to find out the average rate. So let it be between these 2 points, right? So what you will do, we will just extend this point down. You will get the time interval T1 and T2, right? And when we are just extending it toward the y-axis, we get the two terms of product here, that is P1 and P2, right? So just finding out the difference in the product, right, concentration of products, right, upon the time interval, we can find out the average rate, right? So but when we are finding out the instantaneous rate, here also we will do the same thing, that we have to just draw a tangent at a point or at a particular instant where we want to find out the uh, rate of the reaction, right? This is time here, this is the concentration of product. So here let it be this point, point P, where we want to get the rate of the reaction, instantaneous rate, right? I think this word is clear now, what is average rate and what is instantaneous rate. Average rate, we have been given a time interval is there, T1 and T2, whereas instantaneous rate, a particular moment or particular time will be there. Now this is this point, right? What we will do, we'll draw the tangent to this point, right? And then we are just going to drop the line so that we get the a triangle formed here, so we can find out the slope of the tangent here, right students? So when we do it, so the instantaneous rate, that is d of, in term of d product, right, dp upon dt will be the slope of this tangent, right? So and that is going to be slope of tangent is oa upon ob, right student? And how you will get the value of OA? You are just going to extend it toward y-axis. You will get the OA value and OB value. When you just drop these 2 points on the x-axis, you will get the OB value, right? That is, it is going to be OA upon OB, right? Now one more thing is there, if you just watch very carefully the pattern of the graph, the graph is not linear, right? That means the rate of the reaction will constantly change with time, right? So the graph which we get for the rate of the reaction, whether it is in term of product or whether it is in term of reactant, it is always a non-linear, right? That shows that it is going to change with the change in the time. That is, rate of the reaction will change with change in time.